Right. Enhanced Interior Gateway Routing Protocol. This this routing protocol is designed by Cisco itself, and it was designed really a bit early when network was just booming. EIGRP was there. Not EIGRP, IGRP was there. Correct. The the protocol IGRP is later enhanced. That's why enhanced interior gateway routing protocol. This IGRP was a classful protocol. Now, what is that classful means? This protocol will not look into the actual mask on the interface. When it finds the first octet ranging between 1 to 126, it will say this is /8. It may not be /8. The user might have subnetted as /24, but IGRP never focuses on the actual prefix length that is there on the interface. IGRP never advertises the actual prefix length. So the receiver, one who receives the update, needs to assume the default mask based on the number. If the number falls in between the range of 191 to 223, then it is assumed as class C address /24 mask. But it may not be /24. Sometimes it may be /30. Do you understand what I say? I'll try to put it in another way. Classful protocols never advertises mask. If mask is not advertised along with the network while advertising, the receiving routers need to assume the mask. Assumption is based on the number, the first octet number. Class A number is between 1 to 126, right? Class B is 128 to 191. It's 191. And then class C is 192 to 223. So when the advertisement comes, the receiving router will check for the first octet. If the first octet falls in between these two numbers, then it will take it as /16. So that's what I said, assumption. It needs to assume. But the actual mask on the advertising router may be different. Not 16, it may be 24, because subnetting might have been done. So today everywhere we see subnetted networks. So the idea of using IGRP was dropped because of that reason. EIGRP is introduced, which can support variable length subnet mask. It's not a fixed length subnet mask. Length of the subnet mask may vary depending on the requirement. You see, variable length subnet mask. For class B, what is the actual subnet mask? 16, isn't it? That is fixed. That is fixed. That is classful. Classless protocols are the protocols that can read the actual mask on the interface and advertise the actual mask to the neighbor. Classless protocol can advertise the actual mask on the interface to the neighbor. Classful protocols, they don't advertise any mask, so the receiving router will need to assume the length of the mask depending on the number on the first octet. Not only that, the enhancement also like bits that is used to calculate the metric. Eigrp was using only 24-bit to calculate the metric. Eigrp was using 24-bit. Eigrp uses 32-bit. So you got more number of bits, so you will have more granular metric calculation. We'll talk about the bits later, it's coming. I'm just trying to explain what that E means. Enhancement means what they did to Eigrp is they made this protocol a classless protocol. Earlier it was a classful protocol. Enhanced interior gateway routing protocol. I told that this protocol was designed by Cisco, but now this protocol is like an open standard protocol. Anyone can use it. It's no more a proprietary. Cisco made it as open standard so that anyone can use it. They want other vendors also to use this. So it's made free now. It's no more proprietary. These many points here will give us a very good knowledge on what Eigrp is. The features of Eigrp. The picture explains that Eigrp can support a really large network if we do proper summarization. From this picture, that's what we learn. You see, 10.1, 10.1, 10.1, 10.1, this all starts with 10.1. So instead of advertising /24 mask, we advertise only 16. Anything starts with 10.1 is right here. Anything that starts with 10.3 is down here. Anything starts with 10.2 is down here. We have 10.2.1, 10.2.3, 10.2.2. We have many networks of 10.2. Summarization is very important. Now, every protocol comes under some category. For example, RIP protocol comes under distance vector. If you take OSPF, we will call it as link state routing protocol. When you take BGP, that comes under path vector routing protocol. ISIS is also a link state routing protocol. Now, Eigrp, how do we call? It is called as a hybrid protocol in CCNA, but it is not really a hybrid protocol. It is an advanced distance vector protocol. It cannot be a hybrid protocol, meaning why they call it as hybrid protocol in CCNA. When you learn CCNA, all routing protocols are not explained in depth. They are very small, like Eigrp. You will know how to configure there, not much more than that. OSPF, just configure and few verification. RIP, few configuration. That's all you learn there in CCNA. Now, if you see RIP never learns neighbor. RIP never maintains neighbor table because it never learns neighbor. But OSPF have got neighbor table because OSPF sends hello packet to learn neighbor. If you see RIP, it learns the route updates from the neighbor. OSPF won't do like that. OSPF collects all the link state information to calculate the best path. So what they say here is, see, this Eigrp is behaving like RIP when it learns network. It learns network from the neighbor's advertisement. Like OSPF, Eigrp has got neighbor table. I'm going to repeat again. In CCNA, they advocate saying Eigrp is a hybrid protocol because Eigrp has got some characteristics of RIP and some characteristics of OSPF. In other words, they say it has got some characteristics of distance vector protocol, some characteristics of link state routing protocol. So Eigrp, we can call it as hybrid. That's how they say. To CCNA level of knowledge, you will agree with that. But when you actually have a close look into this Eigrp, you cannot compare this Eigrp with OSPF. Totally different. So Eigrp should be called as advanced distance vector protocol. Because Eigrp having one neighbor table and topology table, you cannot say this is like OSPF. No. Tables may be there. But this is a routing protocol. We need to focus on how they learn the route and how they distribute the route. Eigrp learns route and distributes route, same like RIP only. Same like distance vector protocol. Slight variation, not 100% same. Slight variation, but you don't have any trace of, any fingerprints of OSPF here. The link state protocol, the image of link state protocol, the shadow of link state protocols you can't see. So calling it as a hybrid protocol is okay if you are in a beginner level. When someone says Eigrp is a hybrid protocol, then you can understand they are in CCNA level. Eigrp is an advanced distance vector protocol. We are going to learn how it is an advanced distance vector protocol as we go through many pages. Secondly, Eigrp has got trigger updates. Whenever a change occurs, the change is notified instantly. And when the notification comes, the alteration to the routing table happens immediately. So that the routing table can adapt to the new topology change. The routing table can show the latest updated route. Eigrp is fast in convergence. When you compare to RIP, definitely Eigrp is much faster. If you see RIP, when the network goes down, your RIP takes somewhere around 4 minutes to throw the route outside the routing table. The flush interval is 240 seconds in RIP, which is 4 minutes. Only after throwing the old route, the routing table can accommodate the new route. See, when a route goes down, it takes 4 minutes to throw the old route when the new route is still there waiting to get into the routing table. When the available route there router is not able to accommodate it because of the old route blocking. Eigrp is not that bad. Oh, RIP. It waits for 180 seconds to consider the route as possibly down. And then to throw the route, it takes another 60 seconds. So 180 plus 62, 40 seconds. After that, only the other path information can be processed by the RIB, routing information base, which is the algorithm in every router that builds the routing table. So during this 4 minutes of time, depending on the size of the network, hundreds and thousands and millions of packets might have get dropped. Very slow in convergence. That's not the case here. Here GRP is very fast. Immediate notification, immediate flushing out. And to bring the alternate route to active route, it takes few fraction of seconds. It is because the alternate paths are maintained in a special table called topology table. Eigrp maintains a table which will have the primary path as well as the backup path. When a primary path failure notification is sent immediately, that path is thrown out and the alternate path from the topology table will be promoted as a primary path into the routing table. See, the primary routes are seen only in, no, that's not the way I should say. Routing table maintains only the primary route, the elected route, which can be used for packet forwarding. The routes that are there in the routing table are the only routes that can be used for packet forwarding. The alternate routes will be there in the topology table. We call it as backup route or feasible successor. We'll talk about those tough terminologies later. I'm I'm just explaining you these points, and the details of deep dive of these points are coming later. Again with nice pictures. In that, your question, what are all tables we have, is also there in the third page from here. You ask for what are all table, topology table, neighbor table, and routing table. It's another 3 slides away. Now, fast convergence, it is because of the notification. When the notification comes, immediately it goes and picks the backup path, makes it as an active path, and promotes it to the routing table so that packets can be forwarded by using this new path now. That's not the case with RIP. When a route goes, RIP takes 180 seconds to consider the route possibly down. And then to decide to throw it out from the routing table, it takes another 60 seconds called flush update, flush interval. So flush interval is 240 seconds. After throwing that, it will listen to the new updates and takes if any new path from the broken path comes from other neighbors. Again, RIP never learns a neighbor. Okay, next is Eigrp is not like that. As soon as it gets the topology change notification, it throws the route, and when there is an alternate route in the topology table, it immediately uses it. It is not waiting for someone to give an alternate route. It maintains the alternate route, which is called feasible successor in the topology table. As a result, Eigrp can provide a fast convergence table. When the routing table converges faster, updates faster to the new change that is happening, The traffic can also be fast in convergence. If routing table is slow, then traffic will also be slow. A lot of packets will get lost till the best path comes to the routing table. So, compared to RIP, EIGRP is definitely fast convergent protocol. I told you EIGRP discovers neighbor, maintains neighbor. When I say discover neighbor, it means it discovers, it learns that there is a neighbor connected to me on this particular port. Maintain neighbor, what does that mean? It sends the hello packet every now and then, every 10 seconds. OSP will send hello. EIGRP will send hello every 5 seconds. Every 5 seconds, EIGRP sends hello to maintain the neighbor. As long as the hello comes from the neighbor, whatever learned from the neighbor will be maintained as still available. All the routes learned from the neighbor is available. When the neighbor stops saying hello for 15 seconds, which means neighbor considered as dead, that's why he's not saying hello. And all that I learned from that neighbor is no more valid. Need to be removed instantly from both topology table and the routing table. So this also contributes in fast convergence. Neighbors are discovered using hello packets. Hello packets are sent every 5 seconds. Don't need to worry about how the hello packets will look like, what will be there inside. We'll be seeing every single bolt and nut of this protocol by using Wireshark later. And also it is explained in this presentation. Now we are speaking on this point called fast convergence. Every 5 seconds, hello packets are sent from every neighbor and received from every neighbor. And the dead timer is 15 seconds. If a neighbor stops saying hello, what may be the reason? Reason may be like this: a link failure, or someone might have disabled EIGRP on that link. Actually speaking, the notification will come immediately. But in case if notifications don't come, for some reason, notification got dropped somewhere, it didn't come. Hello packet will also get dropped, it won't come. And the router will wait for 15 seconds. After 15 seconds, decides that the neighbor which didn't send hello has dead. And all the updates which still I maintain given by the neighbor is invalid. So that alternate route can be taken from the topology table via some other neighbors to the destination. What we learned here is a timer. 5 and 15. 5 seconds, 15 seconds. Next. EIGRP is not a classful. It is not a classful protocol. A classless protocol supports variable length of subnet mask, not the default mask always. If you want to have default mask, it supports by default. But if you wish to have different subnet mask and if you expect the protocol to understand it and advertise, EIGRP will do it. EIGRP will advertise the subnet mask that you want to advertise. IGRP was not doing that. EIGRP supports VLSM and discontiguous network. What does that mean? When you have 10.1.00/16, and 172.16.0.0/16 and 10.2.0.0/16. Here it is 10.2 and here it is 10.1, but in the middle, not 10, some other network. We call this as discontinuous network. In a classful protocol, there will be a problem. What problem? We can't use another ink. Okay. In a classful protocol, this will advertise 10.0.0.0. No subnet mask because it is classful, and it won't put this one here. This one is not there because it is a classful protocol. It will not care for those additional bits that you added during subnetting. Same way, this also advertises 10.0.0.0. Now the router here exchanges this info from left to right and right to left, but the left never learns what is being given by the right, and right never learns what is given by the left. Why? Because both are advertising the same info. This, when it comes to alpha, this is alpha. When alpha receives the update, it won't take the update. It will say, hey, I also know 10 network. I'm already a 10 network, which is connected directly to me. Administrative distance is 0. Why will I take Eigrp's 10 network? Eigrp's administrative distance is 90. Why should I take the one which is less trusted? 90 is less trusted than 0. So what I'm trying to say is, whatever alpha gives, beta never takes. Whatever beta gives, alpha never takes. In the discontinuous network issue, in the discontinuous network scenario, this is what called as discontinuous network issue. So as a result, this cannot ping that and that. This cannot be pinged by this member. Members of this subnet cannot ping the members of this subnet. Because they don't advertise. If it advertises 10.1 clearly, then this will learn, I have only 10.2, let me learn 10.1. But when it advertises I have 10 network, it says I'm also part of 10 network. They never learn. But when it is class full, the mask is advertised, 10.1. This will say I am giving you 10.2. Now alpha learns 10.2 because alpha don't have 10.2. Beta learns 10.1 because beta has got only 10.2. A classful protocol will have discontinuous subnetting issue. To distribute route, it is difficult in discontinuous network. They don't learn routes proper. Eigrp is a classless routing protocol, so no discontinuous subnet issue. You have a question? Okay. Now, Eigrp sends only partial update. What does that mean? RIP will send every 30 seconds the complete routing table. Whether there is a change or not in the topology, the updates are sent every 30 seconds and the complete routing table is sent every 30 seconds. Which is going to consume a lot of bandwidth as well as the CPU on the router that receives the update. Because the router thinks that there is something new coming, it processes it and updates the routing table, but it's the same info. Every 30 seconds, it processes the same info, which is a waste of CPU. Whereas EIGRP sends only the partial update. Whatever the change has occurred will be notified instantly without no delay. Partial update. This won't take much bandwidth. This will not take much CPU compared to RIP, which sends the complete routing table. Next point. This EIGRP, Cisco designed this protocol with the different modules. One module of EIGRP is for IP. Another module of EIGRP is for IPX. IPX is also a protocol like IP. Apple Talk. Now, there is a separate module developed by Cisco for those routers that run Apple Talk. Separate module of EIGRP for those that runs IPX. The version that we are learning here is the IP version of EIGRP. We don't work on Apple Talk or IPX in today's world. I have not seen. But that's an older layer 3 protocol. If you will have IPX in your organization, there is an EIGRP for you to learn IPX routes, not IP addresses there. There will be different address for IPX address, IPX network, Apple Talk network. So EIGRP is a routing protocol for IP, Apple Talk, IPX, all of this. So Cisco has not only developed this for IP, also for other layer 3 protocols. That's the information we get here. It supports multiple network layer protocol. That's what I just said. Network layer means what? Layer 3. Layer 3 protocol is IP, IPX, Apple Talk. There is also an IPv6 version of EIGRP. Yeah. See, with the help of IPv4 EIGRP, you cannot advertise IPv6. There's a separate algorithm. There's a separate EIGRP module. You have to enable that EIGRP if you are going to use IPv6 in your environment. Same way. If you are going to use Apple Talk, you have separate module, separate EIGRP, IPX, separate EIGRP. And each module are independent of each other, meaning, as I said, you cannot run an IPv4 EIGRP and expect IPv6 to be advertised. You need another one. They are totally independent. They are separate. They are different. They cannot support. They don't have any compatibility between these multiple network layer protocols. EIGRP is not having that compatibility. You cannot run one EIGRP and expect that EIGRP to support both IPv6 and IPv4. No, you got to separate independent modules. Next, EIGRP supports 100 hops by default. But if you want to extend it, you can extend it up to 255 hops. It's flexible. By default, it is more effective if you have a number of hops less than 100. But when you do proper summarization and reduce the number of updates that will be advertised, you can accommodate more networks, more hops. So you got a flexible network design. And we can have multiple autonomous systems of EIGRP if necessary. Say, for example, in an organization, you want to have two different group of routing domain. Then you can give different autonomous system for each routing domain. The advertisement of domain 1 will not go to advertisement of will not go to the routers of domain 2 and vice versa, because they both belong to two different autonomous systems. Yeah, so network design is flexible. When you have EIGRP, you can have your own number of hops or number of autonomous systems, etc. EIGRP is not using a broadcast as the medium to advertise. If you take RIP version 1, the updates are sent as broadcast 255, 255, 255, 255. RIP advertisements are sent as broadcast, which is very bad. Why? Because every device can listen to the conversation that is broadcasted. Anyone can. If someone is broadcasting, whoever tunes to the frequency, they can listen to the voice, isn't it? Same way. Broadcast is like shouting in an exam hall, calling out some name. That name belongs to a person, but because it is being shouted, everyone who writes the exam will get disturbed for a while. They listen to the name that is called because it is sent as a broadcast. Everyone is listening now by stopping their exam. And then they go back to the exam because it's not their name. But that one person stands up and responds to the name. But the damage cost is heavy. The entire exam hall people's attention were, for a moment, taken away from the exam mode. That's that same impact you will have in network also when you do broadcast. When a packet is sent as broadcast, printer will also receive it. Printer will also say, I own this packet, because it is written to everyone. Broadcast means what? Everyone. To anyone. So whoever receives the packet will say it's mine, and they will open the packet. After opening only they understand nothing in it, because it's a RIP advertisement. How a printer will understand? After processing, when it don't understand, it drops it. So then there is a waste of CPU. Waste of CPU on the routers that don't run RIP. Why will RIP update be processed by a router which don't run RIP? Broadcast is bad. Later, RIP is made as version 2 with the multicast address 224.0.0.9. RIP version 2 uses multicast address 224.0.0.9. What does that mean? When the RIP update is sent with this address 224.0.0.9, it means that, are you a RIP router? Open this packet. That's the meaning of it. Are you a RIP router? Open this packet. So when a printer receives that packet, it won't open because it's not running RIP. When another router receives the packet, it won't open because that router don't run RIP. When a RIP running router receives the packet and reads the destination address 224.0.0.9 as a multicast destination address, it says, it's mine. Yeah, I have RIP. It's mine. I'll process it. So not everyone will process when it is sent to a multicast address. Only a member of that multicast group can process it. All the RIP running routers will form group, and the group is identified by 224.0.0.9. RIP version 2 group is known as 224.0.0.9. Same story in Eigrp. Eigrp also uses multicast address 224.0.0.10. That is 9, this is 10. 224.0.0.10. When you enable Eigrp on a router, it says, I am a member of Eigrp. How it says that? By saying I'm part of 224.0.0.10. You won't see that in the router. You don't configure that in the router. That is inbuilt. When you enable Eigrp, that's the multicast address that would be used, and they all form group by using that one address 224.0.0.9. So if a Eigrp router sends a packet to 224.0.0.9, only those group members, only those Eigrp running routers will take ownership of the packet. The rest all will ignore it. Multicast is good. Multicast is same like in the exam hall. Teachers enters, someone enters with maybe a label, and how can I say? Okay, it's written in the question paper. Whoever belong to commerce group, you need to approach the supervisor for this extended support. So not everyone is going to demand for the extended support from the supervisor. Only those people who have got that word mentioned, only the commerce. This exam hall has got computer science, commerce, physics, biology, all department in the exam hall. But only commerce people response, no other one, other people. It's not a disturbance to the whole group, the entire members of the exam hall. And unicast is very straightforward. Someone enters and calls, no, not calling, going straight to the person in the exam hall, not broadcasting. This is unicast. The supervisor knows the person whom he wants to talk very well. He knows him, goes straight to the person and talks, which is not at all a disturbance for others. When broadcast is sent, it turns everyone's attention. When the supervisor shouts from the friend a name, though name belong to one person, it disturbs everyone. See, Eigrp uses multicast and unicast instead of broadcast because broadcast is bad. Next is like RIP. Eigrp also have got auto summarization. Automatically, the network will be summarized to classful range. And that summarized network alone will be advertised on all the links. But manual summarization is not auto summarization. Manual summarization is if you want one particular point, if you want one particular interface to summarize in a different way other than the other interfaces. I have 5 interfaces on the router. 4 interface, I want summarization like this. But one interface, I want summarization like that, not like this. which is possible. We call it as manual summarization. We'll go in deep in coming classes. What I'm trying to say is you can have auto summarization along with that you can also have manual summarization on the same router. They are not the same. In Eigrp, there is an algorithm called dual diffusing update algorithm. That's the name of the algorithm. Diffusing update algorithm. What does this algorithm do? This algorithm is responsible for picking up the best low cost path with 100% loop free guarantee path. The responsibility of this protocol is to pick the best path, not only the best path, it also ensures that there won't be loop if the path is used. So with the help of this dual algorithm, Eigrp can guarantee 100% loop-free classless routing. Now, some protocols, if you take, configuring on LAN and WAN will be different. Configuring on LAN may be easier than WAN, but Eigrp is same. Configuring Eigrp for WAN and for LAN is same. You will understand this point very well only if you would have worked on ASR routers configuring EBGP and IBGP. In ASR routers, when you configure IBGP, it is easy to configure IBGP. Whereas EBGP, you have to write policies, in and out policies, and only then EBGP, the WAN will work. Actually, Eigrp is not recommended to use outside the autonomous system. Eigrp is only IGP protocol, interior gateway protocol. But here they say you can also use as EGP protocol if you wish to. And the configuration is not complex. It's same like LAN configuration. I've seen very few customers using Eigrp between autonomous systems. Mostly they don't use Eigrp, they use OSPF or ISH. And if they use Eigrp, they use only within the autonomous system. So this point is not that important. Configuration is easy for both WAN and LAN. Okay. If someone wants to use on LAN, they no need to do any research whether what command I'll put and all this. Thank you, dear. Okay. Sorry. So the last point here is the load balancing. You see, RIP, OSPF, ISIS, they all support equal cost load balancing. If you have 4 paths with same cost, all 4 can be used by OSPF, RIP, and OSPF, RIP, ISIS, and Eigrp. They all support equal cost. But other protocols, what they cannot support is unequal cost load balance. This only Eigrp can do. Only Eigrp can support unequal cost load balancing. No other protocol, no other routing protocol supports unequal cost load balancing. Right, more in depth of all this, what I have spoken today, will be coming. in following classes. Do you have any question?